All right, we are back for another edition of Serverless Office Hours. I'm pretty excited. Today I have okay. Now we've worked on it. Let's see how I do. You said I could say Max, but is it Maxim?
Perfect. Perfect, Eric.
Nailed it. Hey,
Yeah.
Jeff, go ahead and take us off. That's as good as I'm going to get today. So let's shut it down. So, all right. You're like, who's Jeff? Jeff is our producer. I want to call out to Jeff real quick. They always do a good job, Jeff and Paco. So we are here for Serverless Office Hours. And the reason we have Maxim, or Max, I'm going to call you Max, is because he is a Java legend. Java expert, Java, I mean, all those things. And today we're going to be talking about Java. And so I'm super excited about that. I can't. So I'm gonna take 1 second and tell you about my experience with Java, all right?
Sure.
And then I want you to talk a little bit about who you are and what you do. But
Yeah.
I started this back in '95. I wasn't coding at all. I decided I'm going to learn a language, and I had a buddy of mine say, I said, if you had to learn a language, what would you learn? He said Java. I had no experience, nothing. So I went to a community college, literally an actual class. You sit in the class. I did 2 weeks of it. And that's 2 weeks of it. There we go. And realized that I would never. Yeah, I couldn't do it. It was just too hard. I had no background, and so I ended up dropping the class. And there's really no point to that story. But I'm proud that you stuck with it. And on that note, tell us who you are. You work for AWS. Tell us what you do.
Yeah. So my name is Max. I'm really excited to be here today. And yeah, as you mentioned, I joined AWS a bit less than 1 year ago. And I'm in the AWS Lambda runtime team. So our responsibility as a team
Oh
is to
man.
make sure that the runtime runs smoothly on AWS. So we have Java, Python, Ruby, .NET, Python. So you can even bring your own runtime. So you can run Rust on AWS, Lambda. So yeah, our job is to make sure that everything looks good, that the patching is doing okay, that we do not break customer code, that we deprecate runtime when it's no longer in use or the LTS is over, bring new runtimes, new major version. So yeah, this is what we do in the runtime space, making sure that the performance is still okay as well.
I love this. And where are you based out of?
So I'm in Dublin. I've been
Okay.
living in Montreal for the past 10 years, but yeah,
Okay.
moved to Dublin. Yeah, 1 year ago exactly.
I can hear your Irish accent's pretty thick.
That's maybe the first time that someone is telling me that I have an Irish
That was a
accent
big
when
fat
you're
lie.
trying
That was a big fat lie. Yeah. So this team, they do. Lambda was the first kind of ephemeral type. Serverless. And so there's a lot of magic that happens. I don't think they like me to use the word magic. Probably have an HR call later, but we'll see how that goes. But there's a lot of magic that happens, and your team really maintains that and does that. And one of them, again, is making Java work in an ephemeral state, in a quick up and down.
Yeah.
And so I kind of want to talk about that. First of all, today we're going to tell them what we're going to talk about today, and then I'll lead us into that. So
Yeah, so one of my passion is like really performance. So I'm really
okay,
enjoying performance and performance monitoring. Uh,
yeah,
so what we are going to cover today is how to measure performance and how to detect bottleneck, how to find like nasty pieces of code that does not run super smoothly on AWS Lambda, how to pinpoint them and how to fix them. So that's what we're going to talk about.
I guarantee you, if you come across a nasty piece of code, somewhere in the comments it'll say Eric wrote this. So, I'm a dangerous. My title is developer advocate. So those of you who don't know who I am, I'm a developer advocate for AWS. I've been here. So I've been here over 7. I'm coming up on 7. So 7 will be in October. Super excited about that. But it shouldn't say developer advocate. I'm an architect. I'm a serverless guy, but who my code is. I kind of live by the mantra of all else fails, then I code, because it's kind of dangerous. But luckily for y'all, Max is not the case there. Like I said, Java legend here. But Java in itself, running it in an ephemeral state, there's some stuff there. I remember going way back. I remember when we announced Lambda, and Java was one of the runtimes, and we had these cold start, right?
Yeah.
And I'm not even talking about in the VPC. I'm talking about just a cold start for Java. And Java was probably the worst one. Is that a fair statement?
That's the first statement. Yeah.
Okay. And why is that? Explain, what is Java doing that takes it
Yeah.
so long to get started?
Yeah. So first, let me take a step back. What is the promise of AWS Lambda? The promise to
Yeah.
our customer and to our developer is you ship code and that's it. You don't need to worry about which version it is, like what is the underlying infrastructure. You just ship code and AWS Lambda is taking care of the rest. We handle patching, we handle deprecating, we handle scaling. So you just ship code and that's it.
Yeah.
So in Java, we need to spawn the JVM, and JVM is a bit slow to start. So this is one of the factor that contribute to latency in cold starts. Another one is deserialization. So basically, what's happening is when an event is coming to Lambda, because Lambda is event based, so you need an event to wake up a Lambda function. Can be a S3 event, can be a DynamoDB event, can be a cron job, something like that. But yeah, JSON will arrive to your Lambda function, and at some point we need something to deserialize it. So we need to transform this JSON object into like a regular plain old Java object. Let's call it like that. And this
Okay.
is taking a bit of time because we need to figure out how to deserialize it. So yeah, that's another piece of latency that is added in Java, which does not exist, for instance, in Node.js, because Node.js, you take the JSON, you execute it, and boom, it's working right away.
Right. Boom. Same with Python. Yeah. So
Yeah.
Okay.
And
So we've done some work around making that faster, and you don't have to go through all of them. But before we kind of dive into the performance stuff, what are
yeah,
some of the things that we've done?
yeah. So I can think about two main stuff that we've done. First one is enable tiered compilation. So it's a
Okay.
specific flag that you can pass to the JVM. So it allows you to speed up the process of starting up the JVM and compiling like in real time your code. So if you enable a specific level of tiered compilation, it will speed up your Java function. It's now
Okay.
enabled by default. So for Java 21, you don't need to think about it. It's enabled by default. I think for Java 18, you still need to pass a flag. I'm not totally sure, but I can link the doc. And so that's once. And the other one is obviously snapstarts. So snapstarts
Okay.
was cool. Enjoying Lambda
Isn't that
magic and
awesome?
using
Yeah.
it. Yeah,
Thanks, Peter.
yeah. So yeah, the other one is snapstarts. So
Okay.
snapstarts is like a great feature,
Magic.
which it's magic. So
Yeah.
basically, you're running Lambda function. We take a snapshot of it and we store it somewhere. And when you want to use it again, instead of spawning a whole new JVM, like doing the just-in-time compilation again, doing local optimization and stuff like that, we just resume the snapshot. And resuming the snapshot is taking far less time than actually spawning a new JVM, doing the just-in-place optimization and stuff like that. So snapstarts, when used correctly, maybe for a hello world that does not make sense. But if you have I don't know, if you preload a cache, if you
Right.
have
Right.
a S3 connection, DynamoDB connection, maybe it's a good idea to prime it. So before taking a snapshot, you can do some stuff, and then AWS will understand that, okay, you want this to be inside the snapshot. I can take a snapshot now and resume it.
Yeah.
So that's the concept of snapshot.
You've got a fan, by the way. PLF
Oh,
591 says "Go Max." Yeah,
nice.
yeah. Very cool. Very cool.
Oh, cool.
So,
Yeah.
the snap start, and I'm going to say it back to you to make sure I understand it here. So when we take so obviously with the Lambda function, there's an initialization period, right?
Yes.
And then initialization only runs when a new environment comes up. All right.
Exactly. Yes.
So just so y'all understand this, we come up. So when I make a call to a Lambda function, if there's not a warm Lambda function up and
Yes.
running, almost said just warm Lambda, and I
Yep.
don't know if you know the rules, but you can't say Lambda. It has to be Lambda function, or Chris Munns will actually fly to wherever you are and tackle you. So
Actually, AWS Lambda function.
there you go. There you go. Yeah. So, but what happens is, and I'm going to say Lambda now that I've explained all that, is if there's not a warm Lambda available, it'll bring up a new environment,
Yes.
and that will actually do the initialization, and then
Yes.
we run the Lambda, and then that Lambda stays warm, and you can reuse it. However, excuse me, I'm going to die here. I've got my throat's bothering me, but if in a Java, when we do snap start, and by the way, snap start works with Python and .NET as well now.
Exactly.
But snap start, what it does is it brings up that new environment. It runs that initialization. This is when you deploy, I believe, not at the when you want to run it, and then it freezes the initialized state.
Yes.
Does that make sense? Okay, good. Yeah. So I want to kind of explain that. So it does all that work.
Yes,
in Java. Yeah.
And actually, it's really up to the customer to optimize this time when the snapshot is taken. So you can be sure to say, oh, okay, I'm warming up the cache. I'm connecting up a pool of DynamoDB connection. So now I consider that my JVM is warm, and I want AWS to take a snapshot right now. And this is my initial state. So now please take a snapshot. So when a spike of request is coming in, restore that snapshot with all the initialization already done. So that's what we call like before checkpoint.
Okay. All right. So I've made you, go down history lane there, or memory lane, and kind of explain some stuff. But let's get into some of this new stuff that we're talking about. And this is obviously the performance tool that you've built, right?
Yes, it's a combination of a lot of different team, but yeah, runtime team is the one who pushed to GitHub. So we got the fame, but it's really like a really big team effort.
Gotcha. Okay, so are you ready for your screen to come up?
Yeah, definitely. So maybe I can talk a bit more, and then I'll share my screen. Yeah.
Okay, you let me know when you want me to bring the screen up and talk. Yeah, go ahead and talk about it.
Yeah. So yeah, as I mentioned, we are going to talk about performance and how to dive and to really understand where the performance is maybe blocking your latency requirement. So first, if you have a very simple Lambda function, you might be in control of 100% of the code because you write your handler, you're not using any external library. So every single line of code, you know what it's doing because you wrote it. But as your application is getting more and more complex, it's very likely that you are going to use third-party libraries, so jars. Yeah, maybe you are going to use AWS SDK, maybe a third-party SDK. Maybe you're doing image processing, so you need another library. Maybe you're doing like JSON serializers. There's a lot of different use cases. And as an engineer, you don't want to reinvent the wheel, and you just want to reuse what is outside. So you are going to reuse some libraries which are well tested, well maintained on GitHub. So yeah, so you just build on top of open source library, so you don't need to reuse that. So that's great. But the downside of that is you're losing control about what is actually executing on your Lambda function. So one solution is to read all the code source of every single dependency that you are going to include, and good luck with that. It can be quite time consuming, and I would not suggest to do that. And another solution is maybe adding some debug logs line here and there and redeploy your Lambda function, tweaking it. But this does not sound like a very good process to actually dive into those performance issues. So that's the baseline. That's the state of the art. We need something to be able to debug and to understand what's happening here.
Right.
And to do that, there is a lot of different tools, but one of them is a profiler. Profiler is not tied to AWS Lambda. It's not tied to Java. It's like a general concept that I'm going to explain for those who are not super familiar with a profiler. So basically, you can see a profiler as a small agent, an agent which is looking at your code, and every microsecond, it will have a look at the execution stack of your running program. Every microsecond, it will look at the stack and say, oh, where are you? You were executing function A. Okay, I'll take a note of that. 1 millisecond, 1 microseconds later, oh, you're executing function B. I'll take a note of that, and so on and so on. So if your function is executed in 5 seconds, it will take I'm very bad at maths, but you get it, like a lot of samples about your stack. And
Yeah.
then you have like a statistical representation of where your application is spending the most of the time. Because every milliseconds, every microseconds, you are able to say, okay, I'm here, I'm here, I'm here, I'm here. So at the end, you have a lot of data about all of that. And one difficult stuff to do is what I do about all of this data. It's like a billion
Hmm.
of data points. So we need some visual representation to do that. And this is where you can share my screen and ta-da.
You got it. Oh boy. And when you showed me this earlier, it's like, whoa. Hang on just a minute. Here we go.
and and ta-da. So I know it's a lot of information. So let me unwind all of that. So
Yeah.
as I
And
mentioned,
I would
yeah,
ask you to blow this up, but I don't think it'll help. So I mean, it's
I,
it's pretty crazy. Yeah.
yeah, I can zoom it a bit.
Okay. Yeah. Yeah.
So so yeah,
Yeah. That
basically,
doesn't help.
okay. So I'll
No. No.
stay
You're
in,
good. You're good. I'm
yeah.
just kidding.
So yeah, basically every single piece of information that the profiler is taking, like a sampling data, is represented here. So the wider a block is, it means that the longer of the more often when a sample has been taken, it has been taken in this specific function. So if a block is wide, it means two things. It's one, the function which is representing by this block is actually long, so it's taking 1 second, 10 milliseconds to execute. So the wider the block is, the longer it is. Or maybe it's super fast, but you're invoking this function a big amount of time. Let's say you have like a for loop which is invoked 1 million times. Even if the for loop is super fast, just the fact that you're doing like 1 million times, of course, the sampling mechanism are more likely to hit this portion of code than another pieces of code. So if we want to dive into this, let's say I can click on. So this is super interactive. So if you click on a sample, it will explain you. It will unwind the stack about what's happening. So for instance, here we see that I have my under request, and I'm going to show the code a bit later. And we can see that I have a calculate Fibonacci. And look, 1, 2, 3, 4, 5, 6, 7, 8. This is stacking. So something is happening here. Like I'm computing the Fibonacci number, and I see that, okay, I have a lot of stuff happening here. So maybe there is something that I need to dive into here. Another one is, maybe if we look at this in my generate and process list, I have this random UUID generation, which seems to take forever. So it's taking 1.31% of all the time. It's a lot just to generate a UUID. So what's happening? Is it because the library is not performing good enough, or because, as I mentioned, maybe it's performing well, but I'm calling this function over and over and over and
Right.
over
Right.
again? So yeah, so that's basically it. This is a flame graph, which is maybe a bit hard to read at first, but then when you get used to it, it's a gold mine of information, because this does not lie. If the width is big, it means that the function is taking more and more sample to execute, and then you might want to have a look at that. So our
Okay.
aim today is to see, oh, okay, this looks good, but I want to generate this out of my Lambda function, and this is exactly what we are going to see.
Nice. Okay. And the way you're approaching this is, I don't want to steal your thunder, but I'm
No, no,
excited
please,
about the
please,
way we're
no,
approaching.
no, please.
Well, so the way you're approaching this is to not be where you don't have to constantly add code to your Lambda function, right? We're
Exactly.
doing it externally so that we
Yes,
can review this, but remove it later if needed, or something
exactly,
like that. So,
exactly.
so yeah, you don't have to go and write. And you're talking to the king of console logs. I
Yeah,
hit this function. I hit
yes,
this function, and that's
exactly.
so ineffective. So yeah. All
Yeah.
right. So
To be honest, if I want to play devil advocate, this is working very fine for like very small function. Like maybe you don't need to set up all of that for like a super
right.
simple function. But as soon as you want like an industrialized process, console log or system out println in Java, that won't work.
Yeah. 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 No, I agree with that.
So yeah, that's a flame graph, and yeah, just
Flame
to,
graph. I have to remember
yeah,
that term. This is really cool. And the shape and the colors matter, right?
yeah,
So
exactly,
yeah,
yeah,
okay. So shape means, so if I have things stacking up, that's more things going on.
yeah. So
And
basically, Yeah,
Right.
everything like on top of this block, for instance, I don't know if it's too small. Let me zoom a bit.
Okay.
Everything like on top of this, it's mean that like the function generate and process larger list, and I will show you the code afterwards. Everything on
Gotcha.
top of that is executed within the concept, within the scope of this function.
Got it.
So if I remove this this function, everything on top of that will be removed. So if I want to understand what's happening, maybe it's not directly in my function, but my function is loading a library, which is loading a library, which is loading a library, but my entry point is here. This is why this is what I route, generate an app process and large list. This is my code, so I know that this is the entry point of a potential bottleneck in performance. So
Okay.
yeah,
Got it.
and
So we have a question coming in, and it's the
yeah,
question I knew was coming at some
yeah,
point, and it doesn't shock me that Peter Smith is asking this. But the question is, what's the sampling overhead
that
time / cost if I wanted to run this in production?
that's perfect. I was about to answer it, but obviously, if you have
We're
like
not afraid of you, Peter. I'm just kidding.
if you have a side process, like it's not exactly a side process, but let's say an agent which is constantly looking every microsecond to your stack and saying, where are you at? Where are you at? Where are you at? Of course, it costs overhead. So the
Yeah.
overhead for here for this kind of application is about 20% of time and memory usage. What I suggest is do that in non-production and
hmm
debug that, because it's very unlikely that you want those to be like long running. Like Lambda function, maybe you are like 10 or 20 different code branches, but you should be able to understand what is happening like during call start and during warm start, and I'm going to
Right.
showcase that. But once you've solved your issue in non-production, you should remove that and put that in production without profiler.
Well, and I'm going to say this, and feel free to correct me
Yeah,
if I'm wrong, but there will be consequences for that.
yeah,
So, what we're looking at here is not really load specific; it's functional, right? It
yeah,
wouldn't change because it's still because if you think about the way a Lambda function works. So let me educate if you're watching. Lambda function is one event. Right. Now
exactly.
we may scale out the Lambda functions to handle, but it's a
Yes,
1-to-1 ratio. So it
ex-
doesn't matter the load.
exactly.
Okay,
Here we're
good.
talking about one single invocation. So you
Yeah.
got it right, Eric. It's one single
What's up?
invocation.
That's right.
So if you have 1 million requests per second and you leave your profiler active to your function, you will end up with 1 million of very similar profiles,
hmm
because maybe
hmm
here and there the CPU does not behave the exact same way, but globally you will end up with the exact same
Right.
flame. So
So, so
um,
the end story on that is run this in development. There's
yeah,
really no reason to
yeah,
run in production. I mean, or it'd be
yeah.
a very edge case to run in production.
Exactly.
So,
And
okay,
I'm going to maybe answer another non-ask question, but some people ask, and this is
do
a
it.
very
Yeah,
valid
they're
question. So
thinking it. Yeah.
why do I need to run that on Lambda? I can debug that locally. Like there is SAM, there is RAE, which is a runtime
hmm
emulator interface.
hmm
We are providing tool, like AWS is providing tool to run and emulate Lambda function locally. So why do I need all of that? I can do that locally. I'm used to run profiler outside of the Lambda world in like EC2 or in other kind of instances. Why is it very specific for Lambda?
Can
Yes,
I go for an answer on that?
yes, please.
Okay, because it's the underlying hardware, right?
Yes, yes, exactly.
That's two
I
for
promise.
two. What's
I
up?
promise. I promise to the audience that we did not
Yeah,
prepare for that. So
we
good
did
job.
not. No, huh?
Yeah.
Yeah, yeah, yeah.
So yeah, basically,
So,
this is a promise of Lambda. You're not in control of the underlying architecture. You just choose what kind of yes architecture, but
that's right.
you just have to choose between
Memory and yeah.
26 and RAM. But yeah, the memory constraint, CPU constraint is very linked to the underlying infra of Lambda, which is extremely hard to replicate locally. You can be close to that, but it's very hard, and I would not recommend to trying to mimic what is live in Lambda, because it can change and you don't know it. Maybe it's not fully documented. So the underlying infra, it's part of the contract of AWS Lambda. What you're shipping is just code, so you don't need to worry about underlying infra. So you should not really trying to replicate what's happening. So that's why I really suggest to run this profiler directly in a Lambda function. Obviously not in production, but in a Lambda function.
Right. Which is so easy to do in serverless. I mean, really, honestly, if you run a test account, that is the same exact infrastructure you're going to get in production. So
yes,
there's
exactly.
no difference.
Yeah. So now I hope I convince our audience that this is something that we should do. So now let's see how we do it.
Hey, you need to know that because I got that right with the whole infrastructure thing or underlying infrastructure, I'm adding Java to my resume.
Okay, nice. I will
I
endorse you.
obviously know Java now, so you know.
So here, can you see my screen? Okay, yeah.
I can. Yeah.
So here is my existing function. So I'll show the code in a moment, but let's assume that this is like a classic Lambda function. If we look at the configuration and the environment variable, this is only what needs to be added. So one is a bucket name, because after every single invocation, a process like a profiler will upload the results, so the flame graph, to a S3 bucket. So you will be able to view it, because obviously Lambda is ephemeral. You don't have access to the underlying storage. You have access to /tmp, and this is actually where we store the flame graph before sending it to S3. But it's not super convenient to retrieve file from TMP if you don't have something like that. So you specify the key of the name of the bucket. Here it's max day profiler demo, and I'm going to show that. And the other one is Java tool option. Java tool option is a very common configuration environment variable. I talked about the Java tiered compilation before. This is another option of Java tools option. And here you see that I set a Java agent, which is a profiler extension. So where this /opt is coming from, it's actually coming from a layer. So what you need to enable profiling into Lambda function, you need three stuff. You need two environment variable. One is, okay, enable the agent. The second one is where I'm going to upload the profiler. And the second one is a layer, and the layer is a profiler. And this layer is fully open source, and I'm going to, I don't know if you can paste the link to the GitHub repository. This is fully open source. So in runtime, we are really aiming toward open sourcing those kind of experimental extension. The statue is experimental because we want to gather customer feedback and developer feedback to see how we can improve, and maybe someday put that in GA. So the code is fully open source. So you can build the layer yourself. There is a full instruction, detailed instruction on GitHub. You can upload the layer and attach it to your existing function. So once again, you don't need to redeploy your Lambda function. If you lost your code, that's maybe not fine, but it's fine to profile your Lambda function. You don't need to redeploy. You just need to attach a layer and add two environment variables. So no code modification.
All right. So I have added, while you were doing that,
awesome.
So I have added a couple things. First of all, just Lambda layers, and what are they? Right. And so grab this out of these, because Lambda layers are they've been around for actually quite a long time, but not everybody knows about them. And then here's a list of the information you just gave. So
awesome.
Right.
So yeah, I can maybe screen share it. So yeah, this is let me zoom a bit. This is a GitHub repository. So this is where our Java lib are living. If you go to experimental AWS Lambda Java profiler, and this is exactly what I've shown you. You have the how to use a Lambda profiler, the quick start. Feel free to open an issue, a pull request to make it better. We already have like 2 pull requests and 2 issue solved. We released that last month, I think, and we have one AWS hero who was really keen on testing that. He gave a lot of good recommendation. We incorporate them, we merge it, and boom, this is the power of open source. So yeah, every documentation is here. So what's happening here? If I invoke my Lambda function, I will do live because I like live demos. I invoke my Lambda function. So it will do on purpose a lot of computation. It's not a real Lambda function, you will see in a moment. But yeah, I can invoke a couple of times here. And if I go to configuration,
it's a real Lambda function. It just doesn't have a lot of functionality that you would
exactly, yeah,
use.
exactly,
Okay,
yeah,
it's
yeah,
like,
yeah.
what do you mean not a real Lambda function? I got you
Yeah,
now.
it's
So,
a real
yeah,
Lambda function, but yeah,
okay.
the code inside, I will show
But it's
you.
just,
Yeah.
yeah. That's the fun
So,
thing of building demos. It's like, what will I do in this demo? So
yeah,
yeah, no, I understand that
yeah.
statement.
And you will see all my demo are about pizza. I'm a big pizza lover.
Yeah, man, you and I are gonna get along great.
So as you can see, the bucket name is profiler demo. So if I go to my S3, I have my bucket 2025, April 22, perfect, that's today. And I have two different functions. So let's go to demo profiler. And then you can see here are all my invocation ID. And if we sort by time, we have here 7:29. This is exactly my time in Dublin, so real demo. And if we have a look at that, we can open the profile, and this is exactly what I've shown you before. So this is a flame graph out of your Lambda function. So if we click on this, we can see that, but let me show you the code first. Yeah. So
Is
what I'm
that
doing,
creating and I can't read can you go back to the flame graph for real
yes,
quick
sure.
second? Is this creating that's not just an image, it's a website.
Yeah, it's HTML file, and
HTML file. There's
and it's like a
I'm super
self-contained.
technical.
It's a HTML file which is self-contained, so you don't
Yeah,
need any external resource,
gotcha.
and it's
Okay.
basically a SVG, so you can zoom in, zoom out. So
Gotcha. Well, I was gonna say you were interacting with it. At first, I thought it was just an
yeah,
image or a JSON or something like that. But your program is doing this. This is super helpful.
yeah. So this is
Okay.
based on, maybe I should have mentioned before, this is based on Async Profiler, which is an open
Okay.
source tool. So the project here, what I'm showing up is wrapping this existing open source library into like a very friendly user product. So a layer, an extension. I'm not going into too much into the detail, but it's basically an extension running alongside your Lambda function, which will
Okay.
take snapshots using Async Profiler.
Got it.
So yeah, this is the flame graph. And if we look at the code, I want to show you something. So this is the handler. So if you write a Lambda function before, you are super familiar with what's happening here. And then we can see that I'm going to perform matrix multiplication, generate and process large list, and calculate Fibonacci.
Okay.
And if we look back at this, and there's a little search button. If I type Fibonacci, where is it? Or maybe it's not the same. Let me process. Let me refer. I think it's not the right one. Yes, or it's generate. So let me try again. So generate. If I search, you see now
There
it's
it
in
is.
purple.
Yeah.
And
Okay.
generate and process largest, it's exactly the same name function that my code is in here. So I can
Got
very
it.
easily link my code source and the flame graph. So let's see what the flame graph is telling me. So I can click on it because once again, like every single block on top of this block means that this latency or these samples are coming from this invocation of this method in my Lambda function. So if I want to dive deep into what's happening exactly in the scope of this function, I can just click on it, and now it changed the base. So instead of looking at all the invocation, now 100% of samples are only this Lambda function, only this method, sorry. And here is what I can see. It seems that I'm calling java.util.random UUID, and this is taking, if I click on it, 455 samples. So the profiler eats this function 450 times. So what's happening here? If we look back at the code, and I'm looking at this generate. Okay, so now I have this for loop, and my for loop is from 0 to list size, and list size is 100,000, so a lot of iteration.
Yeah.
And inside of it, I'm doing like this UUID random ID to string. So what's happening is here, maybe this function is super performant, but due to the fact that I'm invoking it 100,000 times, this is why I'm seeing such a huge spine-wide block in my profiler. So by doing this, I can now check that if I reduce the number of iteration, how it will behave. So maybe I can redeploy a Lambda function by fine-tuning this number of iteration. Do I need like a random UUID in every loop? Maybe I can compute it outside of the loop and doing some computation inside the loop. So this is really helpful to really understand what's happening, because of course here you see like random UUID is calling secure random next byte. I've never heard of this function, and this is not my code. I'm not writing this. What I'm writing here in my application is just give me a random UUID, and I don't know what's happening behind it.
Right.
So
Right.
by looking at the flame graph, I can now understand, what is the primitive that Java is using behind the scene. And if we want to be even more curious, I can see, okay, so next byte, what it's doing. Then it's opening a filter input stream. So I can dive really, really deep into Java internals to really understand what is happening when I'm calling this function. Do I want this library, or should I use another library which does not bring this kind of overhead? So that's the whole point of a flame graph. You
Nice.
can
So
be
we have
very, very deep.
another serverless celebrity among us here. So AJ has said, dang, this is awesome. I had no idea so much wall clock time was spent something called Java. So I don't know if you have any comment on that, but yep. So AJ stated that. So
yeah, I can say hi to AJ. AJ was a former coworker of mine. So hi, AJ. AJ, I think he's a big fan of profiling as well. So the Java shade, yeah.
All right, so I don't know if you have more demo. I have a few questions, but I want to wait till you
please go ahead. I really want this to be super interactive. So
okay, so and if you're not asking questions, I'm asking questions. So if you all have some questions for Max, definitely throw them out there. He's obviously a pretty sharp guy, so let's stump him if we can. We got an awesome work Max here. So yeah, I agree. This is super cool. So talk to me about earlier we talked about, okay, we can apply this without changing the code. We can just say, okay, hey, I want you to work on that. We talked about development. We talked about in production. How do you see configuring this, or how would you approach this so that I didn't have to do a lot of work, but I know it worked in production, or it worked whenever I was in development. It was always running in development, but not in production. How do you see the deployment process and setting work?
Yeah, that's a very good question, because of course it's very unlikely that you're going to log into the console, tweak my environment variable. So
exactly,
don't do
that. Bad. SAM, CDK, Terraform.
Exactly.
Yeah.
I'm super happy that you mentioned SAM, because if you look at the GitHub repo,
of course I would. I'll go put on the squirrel costume if I have to.
Yeah. So if we look at the example, there is a CDK, and there is a CDK example. So let's go to not this one. Sorry, where is it? The extension. Is it sample? Extension example. Oh yeah, function profiling sample. So we have sample function here, and I'm not sure why. It seems that we are missing a file here. Do we?
I didn't do it. I lose things all the time, but you can't blame me.
That's cool. That's the whole point of showcasing our work.
That's right.
It's supposed to have a CDK template, so you can super easily deploy that. That's great, because now I think we might have forgotten to commit the file, so that's good. But yeah, to the point, it's please don't use the console to do that, and use like AWS provided tool, or you GitHub Action to deploy that. You can use SAM, you can use CDK, you can use AWS CLI, you can use serverless framework. You can use, to be honest, the tool, it's really up to you. Which tool do you want to use? But it needs to be industrialized, because you don't want to misconfigure it and then boom. Can you imagine, like, you deploy that to your production environment, you forgot it, and then your S3 bucket will be filled by million of request IDs. So be careful about deploying this.
So as an operational, so let's say I'm running, I'm a large company. I've got 400 serverless developers.
Yeah.
I could literally come in and say, okay, this is an operational layer. It should be added to every Lambda function. It sits somewhere else. It's shared out. We've
Yeah.
done the permissions and all that, and everywhere. And then, can I disable or enable this profiler through the environment variables?
Yes. So
Okay.
yeah, exactly. So what is happening is a layer is really decoupled from your Lambda function. So you
Right.
can have one layer and like thousands of Lambda function using one
Right.
single layer.
Exactly. Yeah, that's what I'm driving at. So I
Yeah.
could literally say, okay, because when you're doing a Lambda function, you can set up your IAC to say, when I'm in production, this is what these variables. You can use SSM. There's a lot of
Yeah.
different ways of doing it. But
Yes.
what you're basically saying is, when I'm in production, this is turned off. It's still
Yeah.
there.
Yeah.
It's in this layer that's out there. It's not hurting anything. It's still
Yes.
there, but it's turned off. When I'm in, and I'll flip that on and off in development, but
Yeah.
I would just run it in a development.
Yes.
So,
And and and
yeah,
and to
go
your
ahead.
question, even if the layer is attached, you can just remove this Java Tools option. This won't
There you
start.
go.
The extension won't start, and then it will be an op. You will,
There you
to be
go.
honest, you will still pay a bit of overhead during in each duration because we still need
Good
to
call.
download this layer. This layer is
Right.
super small. I think it's 3 MB, but still,
Right.
you don't want to pay useless. When I say pay,
Well,
it's like
yeah.
in terms of milliseconds. But yeah, you can definitely disable this Lambda Java
Okay.
Tools option environment variable, and boom, it won't upload to the S3 bucket.
Well, and I guess it would come down to, and I'm probably doing a rabbit hole a little bit, but I guess it would come down to, are there other global things that are in that layer so that it's worth loading? If that's all you're doing, then yeah, we can set that parameter based, same way we're doing the environment variables. We can set the layers based on environments as well. So
Yeah,
that's easy enough to do. But
yeah,
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 that's really cool.
yeah.
So
So it comes with another set of environment variable if you want to configure a bit more. In the README, we have a lot of different, not a lot, but some optional environment variable. So for instance, if you want to add debug logs when the profiler is sending an item to an object to S3 bucket. So if you enable this, it will add some debug log lines to your CloudWatch log group. You can specify a profiler stop command. So this is really tied to, I'm not going too much into the detail, but this is really tied about what kind of regex classes do you want to be inside the profiler. If you have, you can prefix your profiler, you can prefix your classes and say, okay, I just want everything about AWS Lambda, but not about a third-party library. So it will omit this third-party library from the flame graph. Can be useful in some case. And finally, there is communication ports because the extension and the runtime are communicating with port 1, 2, 3, 4. In the unlikely event that your Lambda function is actually using this exact same port for something else, well, you can
yeah,
we got you covered, and you can just change this port.
probably not, but yeah.
Yeah,
So
yeah.
So a couple of things. One is, kind of tongue in cheek, but is it regex or regex? So that's my first question. But we won't debate
well,
that here. So
well,
that's
I,
it's a or
I,
is
I,
it
I
GIF or GIF? I guess the same
yeah,
question. Yeah.
as
So
a French-born non-native English speaker, I'm not going down that route. I say regex, but tomorrow
that's fine.
I might say
Yeah.
regex. So I don't know.
No, I'm messing with you. The second question I had, or not question, but I'd like you to take a moment if you can. So we
Sure.
talked about layers. But you're using some extensions here as well, so that's
Yeah.
another technology
Yes.
that we offer. And layers came out first, and then
Yep.
later we said, okay, now we can do extensions, and you can do those either in a layer or
Yeah.
as part of the.
Yeah.
Explain how the extension works and kind of how the resources work, if
Yeah.
you could.
So maybe one question that people have is, okay, I'm sending the profile, but I need actually to send the profile on the second invocation because I cannot send the profile if the invocation is still happening. So what's happening
Right.
is I'm doing an invocation, I'm saving the profile, and on the next invocation, I send the first invocation to S3. That's working great, but guess what? When the function is shutting down, we are going
That's
to
right.
lose all of that.
Lose one.
So to prevent all of that, AWS, not to prevent exactly this, but AWS has released Lambda extension. And extension, you can see that as a sidecar, it's generally packed as a layer. So in the layer, there is an extension. The extension is registered to two events, invoke and shutdown. So for every invoke, we can do some stuff. And for instance, we can start the profiler, stop the profiler, save the profiler to /tmp. And during shutdown, we're making sure that, okay, no more invoke will be eating this sandbox. So we can just take the rest of all invocations that have failed to be uploaded, or just it's the last one, and just flush that to the S3 bucket. So we need an external extension to be able to map those lifecycle events to actually flushing data to S3. Does it make sense?
Yeah, it does. Yeah, that makes sense. The thing I'm curious about, and this, or I actually know the answer to this, but is where the resources coming from? Are they separate resources running the extension, or is it shared with the Lambda function? How does that work?
Yeah, so that's a very good question. So basically, what is inside the layer? It's mounted in /opt. So really, everything is inside the layer, it's accessible by the runtime under /opt. There is a special folder which is opt/extension. So if in the layer you have a folder which is named extension, if in this extension you have if in the extension folder you have a binary or something else, AWS will spin that out as an extension. So don't mess with this folder, because if you
Yeah,
put
that's
in
right.
like a text file or something like that, it will crash your Lambda function, because Lambda will see, okay, I see /opt, I see /opt/extension, I see /opt/extension /toto.txt. This is an extension. I'm going to run it. Boom. It's not an extension.
Yeah.
It's crashing. So it's really a separated process that AWS Lambda is spawning that. So you can have multiple extension. I can't remember.
Yep.
I think it's 5 at most.
Five.
Yeah,
Yep.
I think. And AWS is spawning that binary. And this binary, it needs to first register to the extension API. So you need to do that. In this project, we've done that for the customer and for the developer. So you don't need to do anything. But if you want to write an extension, you would need first to register, like, hey, I'm an extension. And while you're doing this registering, you need to specify which events do you want to be notified. So there is two kind of events, the invoke event and the shutdown event. So while you're registering, you say, hey, I want to be notified for every invoke and every shutdown. And AWS Lambda runtime guarantees you that after every single invoke, it will send a message to your extension saying, hey, this is an invoke. This is the invoke RN. This is a deadline in milliseconds. This is a timeout and stuff like that. So this is how extension is working. You can see that as a sidecar, like a separated process. It can be written in Java. It can be written in Rust, in C++. We don't care. It's a binary. It can be written in Bash if you want.
It doesn't have to be the same that the Lambda function is.
Exactly. The only thing that you need to do, for instance, if you want to run like a Node.js extension and you're choosing Java runtime, this won't work because Node is not installed. So if you want to run a Node.js extension, you need to provide Node binary.
Right. All right. So we go back to this port. When we talk about this port, so that allows the Lambda function, your code, to communicate with the extension or the extension to communicate with the Lambda. It may be either way. And that's what this port is setting.
Yeah, so it's a bit different than that. So what's happening is, so let me go back to this Java tool option. What's happening here is it's spawning another jar, and this jar is really responsible to instrument your function. So you can see that as a little spy, like a little agent, which will hook into your code and say, okay, I've taken a snapshot, I've taken a snapshot, and then the extension is telling like, hey, I've received an invoke, so stop taking any snapshot, pause it, send me the data, I'll send it to S3 and resume it for the next invocation. So it's really the communication between this agent and the extension, not between the customer code, because customer code is untouched. So
right. That makes sense. Okay, that makes sense. Okay, super cool. All right, this makes a lot. So what you're launching is an extension and an agent.
exactly, yes.
Okay. All righty.
And since it's all running in the same like sandbox, I would say, the ports need to be different. Like if the customer is actually
Mhm.
using 1, 2, 3, 4, it will be a port clash, and we don't want to break customer code. So that's why you can modify it.
All right. That makes total sense. Okay. Well, so what we're doing, do you have anything else you're demoing?
No, I think that's it. Maybe I want to show another example, which is a
Go
bit
for it.
more
Yeah.
complex. Like it's just to show you that this is endless possibilities. Like here in my application, I have like a very complex S3 code, DynamoDB, and stuff like that. And you can see that I'm not going to go into the detail, but look at the granularity of how many samples did it take. So if you want to really understand your code, instead of doing console log or a system printout, just use this profiler and you will find all the information you need to really understand what is happening. If a sample is
This
not
is
here,
nuts.
yeah, this is like
Yeah.
automatic. It's fully automatic. You don't need to think about that. Just run the profiler. The profiler will do the job for you. And then obviously the part when you need to optimize and to actually dive into what's happening, well, you still need to go into the detail, but at least the collection phase and the configuration phase has been done for you. So now you have your flame graph. Now it's your time to do the homework to optimize your code.
Man. But I would look at this and probably call you or change jobs. I'm like, oh my gosh, this is overwhelming, which is a good thing. I'm
Yeah,
kind of being facetious there, but there's so much information here.
yeah.
Now, let me ask you a question. Maybe this is a dumb question, but I'm okay with that. Can I apply this? Can I run this against a Python app, or is
Oh,
this
so that
Java
that
only?
so let me show you something which is great when you work
I
with.
swear we didn't coordinate this.
Yeah,
It's a great
so
segue, though.
if you look at issues, and this is great with open source because when it's open source, everyone can raise
There we
issue.
go. Yeah.
And look at this. We already have someone asking for
Okay.
the same for C# and Node.js. I'm not going to make any false promises. I don't know, and I'm not aware of the full roadmap of our team. So I'm not going to say, yes, we are going to release that next week. That's
That's
not
good.
going to happen. But yeah, that's totally, at least it's doable. If we have more and more customer raising issue, opening issue, sending up, like a good way for us to know whether or not we want to do that is to see customer reaction about that. Do they like it? Do they create issue? Are they engaged to this kind of project? If yes, I'm sure that we can do something about that. But yeah, as I
Right.
mentioned during the intro, this flame graph, once you really understand how to deal with it, it's forever because it's not tied to Java. It's like if you look at the profiler for
Right.
Node.js, for Rust, it's always the same stuff. It's not the same primitive underlying, but at the end, it's
Sure.
doing a system calls underlying. So yeah.
Okay. That makes sense. All right. Well, I'm looking to see if we have any questions that we missed. If not, so we are wrapping up here. We got a 5-minute warning here. So, anything else? Any shameless plugs you want to throw out, Max, before we wrap?
That's no, I didn't think about that.
Okay. No,
No,
you're okay.
yeah, no, just like we would love to hear about what you think. It's positive feedback, negative feedback. This is the
Yeah.
whole point of being open source. So please raise issue. If you want to engage, create pull requests. We will review them like as fast as we can, of course. But yeah, that's the whole point of being experimental, promoting this to open source. It's to gather feedback and do you like it? Yes, no. Please tell us. Like, is it useful? We would love to see like success story. I think
Right.
AWS Heroes has published a blog post where they're using this exact same profiler in early phase to detect an issue with snapshots on their code, and they managed to do some wonderful optimization. So I don't have the link here, but if you look on dev.to, if you look Lambda extension, Java profiler, you will find it. It's a great blog post. So yeah, we would love to see a success story about, yeah, I'm using this. It helps solve me the use case. or a bad story as well. Like, this is not working. Like, why are you doing that? That's great feedback as well, because we can fix it and make it work for our customer.
So I found the link here. I'm going to throw it in real quick here so we have it. So if you want to read this, there we go. About AWS Lambda Profiler extension for Java Part 1 introduction.
Yeah,
so
and there's a part 2 as well. It's linked on bottom of
it's linked.
Yeah,
it's in there. So
it's a very good story. I think he has done a very good job storytelling it, like going from here to there, using the profiler to debug their issues. So, yes.
Beautiful. Thank you so much, Max. This is super interesting. If you're not familiar with Serverless Office Hours, we do this every Tuesday, same time, same place. Julian will be back next week. I have been covering for Julian, but like I said, you really can't tell the difference. I've got the long hair like he does, so it's not true. He doesn't like it when I say that. So, but we're basically twins. So he'll be back next week. But I've loved doing this. Max, I appreciate you coming on and joining us, teaching about this. And if you missed this video, obviously it's on Twitch, and you can go back and catch the rest of it, or start from the beginning. Thanks for joining us. Thanks for watching. And with that, I'll go ahead and sign us out. Again, thanks, Jeff and Paco, our producers. And have a great week. We'll see you next week.
Thank you so much, Eric. Have a good one.
Thanks, Max.